All right, Chapter 4. In Chapter 4, we dealt with nonlinear data, and when we looked at this, we wanted to look at the residual plots. In our residual plots, if there was any parabola or any kind of curve, we didn't like it, or if there was any big fan, like if it was really close together on the bottom and wide apart at the end, or opposite, we didn't like that either. But mainly we were just looking for curves. Uh, Now, in a situation like this, if I have an x variable and a y variable, if we graph these, it actually had something that looked like this. So it had a curve in it. So when I did the residual plot, it had a parabola. So, um, so if you want to find a linear equation using logs, what we would have to do is put this in L1 and L2, and then L3 would be the log of L1, L4 would be the log of L2. And what we would do is we would graph and see which variable um, makes it so that the residual plot is the most scattered. And in this one, it turned out that it was L1 and L4. And so you had some linear equation. And when we did this, we could get an equation that said log of y is equal to 0.25 plus, or minus 2.5x minus 0.002. Now, what we want to do is define our x to be hours and y hat. We should put a y hat in here. Predicted number. Probably should have had some context in here, but oh well. And now, if I want to use our inverse transformations to solve for y, we would take 10 to both sides. So I'd have y hat is equal to 10 to the 0.25 is 1.77. And then 10 to the negative 0.002 is about 0.995. So this would go down, but the x is still up here. And then we'd have 0.995 multiplied in front. Now we don't figure out, we'll do standard deviation later. But that's about all we want you to be able to do in Chapter 4. Now, the second part of Chapter 4 was dealing with categorical variables, which was a huge switch. And when it says fill in the marginal values, what that means is, oops, if I had some columns here, we're just filling in the totals. So totals here and totals here. So you just add up those numbers, put it here, and so on, and then do it at the bottom, and that would be your marginal values. If it says find the conditional probabilities, this hopefully you can see connects to Chapter 6, the conditional probabilities for having 2 concussions. If I just look at this row, that's 11, 22. So now it would be 11 out of 22, or 0.5 of the people with 2 concussions are soccer players. Non-soccer players would be 8 out of 22, and then non-athletes would be 3 out of 22. Now another thing we learned is causation, common response, and confounding. Causation is one thing definitely causes the other to change. Now the way to show causation is through a well-designed experiment. That's the best way to show causation. Common response is if there's some lurking variable out here that causes x to change and it also causes y to change. Where a confounding variable is a lurking variable that only affects the y, the response variable. Now, Now, the only compelling method for showing causation is a design experiment. However, we can evaluate association using these 5 criteria. The association has to be strong, it has to be consistent, higher doses have to have stronger responses, the cause has to precede the effect, and the cause has to be plausible. All right, and then that gets you through chapter 4.